Welcome to the video tutorial on using Apache Spark for large-scale data processing. In this tutorial, we'll learn how to set up Spark, perform transformations and actions on data, and take advantage of its features to handle big data efficiently. First, let's talk about what Apache Spark is. Spark is an open-source distributed computing system that can process large datasets quickly by using in-memory caching and optimized query execution. Now, let's jump into the setup process. You will need to download Spark and set it up on your machine. Step 1. Download Apache Spark from the official Spark website. Here's how you can do it. Go to the Spark download page, select a pre-built package for Hadoop, and click the download link. Step 2. Unzip the downloaded file to your desired installation directory. Step 3. Set the environment variables. You need to add Spark's bin directory to the path variable. Now that we've set up Spark, let's start an interactive Spark shell to execute some commands. In this Spark shell, you can type Scala commands to interact with Spark. Let's create a simple RDD, Resilient Distributed Dataset. RDDs are the core abstraction in Spark, and they allow you to perform distributed data processing. We've created a simple RDD from a Scala sequence of integers. Let's perform a transformation on our RDD. A transformation creates a new RDD from an existing one. We will apply a map transformation to square each number. Now, let's view the result of our transformation. We can use the collect action to retrieve the data from the RDD. The map operation has returned a new RDD that contains the squares of our original numbers. Let's examine that output. Next, let's discuss some of the most common transformations and actions in Spark. Some common transformations include filter, flat map, and reduce by key. And some common actions are count, take, and save as text file. Let's try using the filter transformation. We will filter out even numbers from our RDD. Now, we will collect the result to see which even numbers we have. As we can see, the filter transformation successfully filtered out the even numbers from our original RDD. Up next, let's explore the reduce by key operation with key-value pair RDDs. But first, let's create a new key-value RDD. We now have a pair RDD. Let's use reduce by key to combine the values with the same key. Now, let's collect the reduced RDD and display the output. Using reduce by key resulted in the concatenation of values for each unique key. Now that we have seen the basic operations, let's discuss how to handle large data sources using Spark data frames. Data frames are a higher-level abstraction over RDDs, allowing you to work with structured data. Here's how to create a data frame from a CSV file. After reading the CSV, let's check the schema and show the first few rows. With data frames, you can leverage Spark's SQL capabilities. Let's perform a SQL query on the data frame. Now we can display the results of our SQL query. The SQL operation resulted in a new data frame based on the condition we specified. This is a powerful feature of Spark that supports big data processing seamlessly. As we dive deeper into the world of Spark, let's look at some advanced topics like optimization and partitioning. Partitioning is a vital concept for performance. When you apply transformations on data, Spark handles data in parallel, but managing partitions effectively can improve performance drastically. In this line, we have repartitioned our data frame to 4 partitions. This can improve parallel processing efficiency. Finally, let's discuss how to save the processed data back to storage. You can save data frames in a variety of formats, including Parquet and JSON. This command saves the data frame into a Parquet file, which is a columnar format optimized for big data processing. Now that we've gone through various Spark operations, transformations, and optimizations, you should have a solid understanding of how to process large-scale data using Spark. Before we wrap up, let's recap what we've learned in this video. Today, we set up Spark, learned how to manipulate RDDs, and explored data frames. We also touched on data partitioning and saving data. Spark is a powerful tool for big data processing, and mastering it will enhance your data engineering skills significantly. Thank you for joining me in this tutorial. If you found this video helpful, please like, share, and subscribe for more content.